Paul here today to take us through this presentation. If you can put your questions in the chat and turn off your camera and mute your line, and if you want to ask questions at the end, you can also put your hand up. So without a further ado, I'll pass over to Martin and Paul. Thank you very much.
Thanks, Ian. Good afternoon, everybody. My name is Paul Carter. I work in the Network Rail Intelligent Infrastructure Programme as the Insight tool, which is one of the tools that we're building. I'm the Insight SME and also responsible for rolling out the tool across all the routes and regions within Network Rail. This afternoon, I'm joined by Martin Mason. If you want to do an intro, Martin.
Hello. I'm Mike Mason. I'm the Programme Manager for Development in Intelligent Infrastructure, and I'm the Lead Product Owner for Insight.
And also joined by Rob York.
Hi, I'm Rob York. I'm the Lead Business Analyst and the Product Owner for the track portions of the Insight tool.
Okay, thanks, guys. So what we're going to do, first of all, is just give you a very brief PowerPoint. And then we'll go into a live demonstration of the tool. So I'll just share my slides, which hopefully you can see. Okay, so for those that don't know what intelligent infrastructure is, it's a program that Network Rail started for CP6, and what it does is it builds on a lot of the work we did in CP5. For pulling a lot more data and intelligence from the different tools we've got within the business all into one place. We started doing that. A lot of the work that was done predominantly by people like Martin with the support of others in the business. A lot of it was done in Access databases, in other various different tools. And what we found is the usability of those tools and being able to share the information wasn't as useful as we could be. So as part of the Intelligent Infrastructure Programme, we decided to look at how could we use newer technology, so a lot more web-based technologies, into turning that data into intelligence. A lot of the data is information that is already existing in the business. It might be in 4, 5, 6, 7 different systems. And what we've tried to do is we've tried to A, collate that data into one place, and then B, rather than just presenting to end users more and more data, which we were told was a no-no, it was to then, how do we help turn that data into intelligence? So using things like machine learning, using things like various algorithms, and we can now turn that data into intelligence. So when we present it to end users, they're getting a more informed view when it comes to making their decisions regarding how they're going to manage the infrastructure. It's not just designed for track, so we will have elements for signalling, we will have elements for EMP, civils, S&C, all sorts of different parts of the tool. But the one that we're going to predominantly focus on today is the track element of the Insight tool. The tools we're developing, so not just Insight, but other tools around planning and things like that, are all designed to support other initiatives in the business, so like Safety Task Force, modernising maintenance. And the feedback is that some of these programs are going to rely on what we are building to help some support them and help them roll out. And the whole idea with all of these things is ideally to try and get people off track if possible, and use this intelligence and new ways of working to allow that reduction in boots on ballast. And what we're talking about with everything we're doing with Insight is trying to do the right thing in the right place at the right time, so that we now get into a way of working which is more preventative rather than reactive. As I say, Insight is just one of the tools we're building, and it's all designed, as I say, to turn intelligence and give engineers this intelligence all in one place rather than currently in multiple different systems. And what I'm going to do now is, for the next couple of slides, is hand over to Martin, who's going to talk about the Insight vision, what we've done so far, and what we're looking to deliver in the rest of CP6.
Thank you, Paul. and for flicking the slide deck. So this is our vision for Insight, which, as Paul mentioned, is a web-based decision support tool. The tool is discipline agnostic, i.e. each discipline has areas and ways of managing their data, but the product itself is holistic around common capabilities. So that is the overall view. And obviously other disciplines will build pages that TRAC may utilise going forward. But the concept is that we have lots of feeds coming in from the infrastructure, measurement trains, TEF forms, manual digital forms, and an RCM kit. And what the product will do is it will ingest those data sets, perform analytics and run algorithms over. So it is an example in TRAC. We align all your geometry runs together through space and time at 200 mil, so you can do degradation. And then the product then has different facilities and functionalities based on the user access. So there are pages around managing linear conditions straight off the measurement trains. There are asset information pages, so you can look at specifics around S&C, lubricators, etc. There's the ability to have a linear viewer, so you can look at all your traces and your drainage condition all in one place and at one time. And the thing that kind of holds it all together, or which makes it really powerful, is the RBM regime functionality that sits squarely in the middle there. And what that allows users to do is implement their own RBM regimes or standard RBM regimes, but it will allow you to do it in a cross-discipline way. So as an example, you could say where my twist gets to this level and I've got a wet bed and missing clips and my POE current draw is increasing. And the product will then search for all the data in your area and locate the locations or assets with those parameters. And then to complete the suite, we have a linear viewer and intervention decision support capability around planning, which then historically looks at the work you've done in the past aligned to your traces and condition and can help recommend the best treatment with the problem you're presented with, as well as then be able to look at cross-discipline work banks and access to then plan the best job which you will believe will fix the problem and not cause repeats, etc. Next slide, Paul. Thank you. So Paul mentioned we've been doing this for about 2 years now. We've got a release which Paul will talk to you about next month and the month after. But what have we been delivering, or what have we built? So we've got a role-based tool that is actions that come from the product can be directed to section manager TME level as an example. We've created our cyclic top and track geometry defect review ability, which is about reviewing all of your defects from geometry measure, as well as predicting when those geometry measures and cyclic top data will become a speed restriction or require a maintenance intervention. We've developed our PLPR defect review page, which Rob will show you shortly. We just talked about RBM, so we're in the process now of developing that RBM functionality that will sit initially for TRAC, but then will be applicable to other disciplines. And we are developing TRAC quality review, which is very similar to TRAC geometry, but obviously it's over your 220 SDs. And what do we want to finish delivering in CP6? So to align, as Paul mentioned, with the strategies around the business, we want to finish our missed inspections and risk assessment. So as an example, measurement train doesn't run, the tool will help you mitigate all the issues that were identified in the last run. We want to finish off our intervention decision support, and that is within a discipline, but as a system. So where one P2F or one piece of work in TRAC may impact the performance of a switch or also the overhead wires. Complete ellipse integration, so we've got a one-stop shop for the customers. And then CapEx and whole life asset management. So the P2Fs we developed from OpEx view can obviously be projected out and then be thrown against the capital workbank, which then will give you the intelligence as to whether you can lower cost intervention, defer, or whether you want to do a more intrusive renewal. And we want to leverage the capability in our vision for other data sets or disciplines. So a good example is, once you can see Rob's demonstration of track geometry, we would intend to throw the rail management data through the same functionality. So align through space and time and then predict. Next slide, if I've got one more, Paul. So it's all great talking about the benefits for the for maintenance, etc. But what does the business get? So there's some quotes in there from someone you might recognise, Nick Millington, as well as Rob Lacey, who's working on modernising maintenance. And really, it's just a slide to demonstrate what Insight gives the business, and we hope will be available for CP7. So it helps underpin modernising maintenance. So the RBM regimes that you can implement, as well as being able to put more complex local regimes in, and having a cross-discipline view of P2F means that we can move maintenance to more of a kind of system level view. It supports the safety task force. So it's about planning your interventions correctly, sharing possession and treating root cause, so you don't have to go and do repeats, as well as that potential giving reduction in boots on ballast. Operational expenditure, obviously, so if we can help with cross-discipline maintenance, as well as managing the overall life of an asset through OPEX, then we can get those operational expenditure efficiencies, and it enables CAPEX to be invested in the right place. So we do CAPEX at the moment, obviously very individually in track, and what we want to do is create a view that says, you know, if you commit this work bank, have you considered, you know, the drainage needs doing, and the earthwork is leading to you getting 10 years less life on a renewal. So hopefully that's given you a flavour from a high vision level of what the product is. I think, Paul, you're now going to go into a bit more detail on how we then do the analytics and what the concept about moving from reactive to proactive working is.
Yeah, and if you wouldn't mind answering Mr. Thurlow's question in the chat.
Oh, let me have a look.
Right, so how does Insight support planning early maintenance? So what we're trying to do is, on a traditional P2F curve, we're trying to get very much up the curve, away from the intervention limit, where we potentially only have 14 days to go something. It's definitely away from immediate action, where we only have hours to go and do something in many cases. We're trying to get up to the alert limit level, which can potentially buy us up to a year in theory, although our tool will show you how even the same defect but in different locations will behave differently. We're trying to get anything up to 90 days ahead of that alert limit point. So we've created an alert in the tool called pre-alert, which says within the next 90 days, this will pass AL. We then look anything up to a year ahead of that, of when it's likely to pass IL, or IL if you don't do anything in the tool. And that's the whole idea of what we're trying to do. We're trying to make sure we can buy an engineer as much time as possible to make that optimal intervention, to get all the right access, to get all the right resources needed, to go in there and potentially only go in there once and not having to go and keep going back in again. What does that look like in reality? And in a second, Rob will show you the actual live tool, but here's some screenshots from the tool. So what we've done is we've used in various algorithms and alignment techniques is we align the data from anything up to the last 16 runs of data from the measurement train. So predominantly it's coming from our PLPR and NMT units, although we are looking to introduce data from service trains eventually, and we're working very closely with Hitachi at the moment on this concept. What we do then is we align all that data through time and space, and we create a normalized location for that data, so that in future we're always looking in the same place in the track. And as you can see in the top left hand chart, there's a blue shaded area in the middle. What we do then is we turn that on its side and we take it through time rather than through distance. And what we're looking there is the degradation over time of that particular measurement point, so we can start to see how it's behaving. And then from there we then use linear regression to project that forward and say, well, if it carries on at this rate, then it will pass these thresholds at these time frames. Obviously, each time the measurement train runs, it ingests a new set of data, it readjusts its calculations, and the engineer is fed this information. So if they've already planned an intervention and the degradation is getting worse at a faster rate, it will prompt them to go back in and go, you might want to look at this time frame you've got this intervention planned over, and vice versa. If it slows down, again, you might want to plan a different job into that. Question from Mira. who may be on mute. Okay, I'll push on. If you want to put the question in the chat, Martin or Rob will answer. The other part of the tool then is the cyclic top prediction. So we're doing exactly with looking at visualizing cyclic top and looking at how we can link that to a potential track geometry trigger and how we can predict what the cyclic top outcome, what threshold it's going to pass and how quickly. And we're linking the two together. We can then say, well, here's a cyclic top in this location, but it's not just cyclic top at that wavelength. There's multiple wavelengths in the same location. And then also potentially there's other wavelengths in and around that similar location. We're also looking to bring in PLPR. So when we go live with the tool in mid-June, we will start to ingest the data from the PLPR trains from the imagery, and we'll start to put that into the tool. And an engineer in future will be able to manage their PLPR defects through this tool. We also give a lot more usability of the images that come from OBB. The fact you can zoom right down into almost individual bits of ballast if you want to on some of the images, which is a functionality that's just not available through the current level of PDFs. And then future fate going to the end. So as Martin's already alluded to around RBM, so the tool currently works on track 001 mod 11 thresholds, but we will be able to have the ability for individual users to put in their own RBM regimes, and then the tool will react each time it ingests data according to those regimes. And then the track review and track quality dashboard. So track review currently, again, this is as mandated by the standard, is all done on paper. We're looking to be able to do that through the tool, through annotation within the tool. So you can start to see all your channels in one place on one page. You start to see a schematic, so you understand the infrastructure. And then you can start annotating those traces and save those traces within the tool. And that's the one advantage with this, is trying to get rid of bits of paper, so PDFs, emails, all these sort of things. Is things like historical images can be saved within the tool, and we can keep moving forwards. We don't have to keep churning through filing cabinets to find out what happened last month. And then, as Martin also alluded to, track quality. So in the same way we're doing predictions for individual track defects, we'll also then start to expand that out for track quality over an eighth. What does this mean for users? So through the tool, there is also a risk calculation scoring there. The tool, not prescriptive, it's still a decision support tool. So the engineer does have that ability in there to prioritize work if they need to, due to, say, lack of resources, lack of access. Where do I go to first? What's going to come and bite me first? The prediction level of accuracy we've got hopefully gives confidence to engineers to plan work earlier, that they understand that if they don't leave it, it will degrade at this particular rate. As Martin said, be able to look at cross discipline, so having a lot more data from other disciplines in the tool, we can start to look for analysing the true root cause of the problem. So, rather than just replacing some track or digging out web beds, if you don't fix the poor drainage that there is to start with, why do we do the other bits? And hopefully by doing that, having that true root cause analysis, and then going back to what I said before about right place, right time, doing the right thing, we get fewer repeat faults. And we know there's a focus on reducing repeat faults in the business at the moment. By buying that better time and that longer time, we can get better access planning, so we can go and negotiate with a TOC or a FOC to get that better access. Might only be we need an extra hour, 2 hours, whatever, cancelling first and last trains, just to give ourselves that chance to do the optimal fix. That means we only need to go in there once rather than disrupt services multiple times. And the tool has lots of different ways of grouping interventions. So you can group by type, by ELR, by track ID, by mileage, all sorts of different combinations you can filter within the tool, and therefore come up with a very informed decision. So what I'm going to do now is hand over to Rob, who's going to show you the live tool with all the perils that sometimes gives us, but he's going to go into the actual physical tool now. Over to you, Rob.
Yes, thank you, Paul. Okay, let me just take control of the screen. So hopefully everyone can see that now. Okay, so excellent. So what I wanted to do was to show the Insight tool and what we've developed. This is actually the test environment, so any updates I make to this aren't going to be reflected in reality. And I'd give a sort of practical example of what we can use Insight for, and potentially how it can change the way that track maintenance teams might be able to work in the future as a result of this. Okay, so Paul, if you don't mind just looking out for any questions, and
yep,
I'll stop if need be. Okay, so as you log into Insight, this is the home dashboard. So this is what the page you see when you first log in. It's configured for me as let's say a track maintenance user. So therefore, all the numbers we see here are relevant to in this instance, section manager, DIDCOT section manager area that I've been set up in a tool as belonging to. And it's also set up, as Martin said, it's a cross-functional tool, so I've set up myself as a track user. As Paul sort of explained earlier, the idea of one of the outcomes of Insight is to sort of move us up the P2F model. So if I run through some examples here of our alert level and pre-alert level track geometry faults, I can click on that widget and it's going to load up now all of the defects I've got within my section that are of a pre-alert, so they're going to become alert level within 90 days, or have exceeded the alert threshold but not at intervention level. On here you can see that I've got various defect types and the information about where they are, the severity and so on. What you'll also see here is a status. So what it's done is filtered down to all of those defects that require some kind of action. So they're pending review because I haven't looked at them yet, so they're new defects. Or we can have this, we've got this one here as an example that says it says review planned intervention. But what that means is that this defect was recorded in a previous run. It's still open, so I haven't remediated it yet. But it's, and I've planned some work against it. It's then been recorded on subsequent run, which means, but the prediction date has changed. So the work that I've got planned might not be relevant anymore. It might be too late, or potentially it's too early. So Insight will automatically change that status and say, have a look at this particular defect because you might need to change the work you've got planned against it. You can also see on here that we've got a risk score, which is at the moment we've set it up to basically be an indication of how far we are away from that defect being due to be fixed. But it's in the future we want to develop that further, so we start to take in consideration a bit more the level of impact that we might get for this defect. So, for example, where it might be in the network, is it a critical part of the infrastructure which might have a bigger impact? And then we've got a reoccurrence. So again, this is using that concept that, as I said, that I was explaining for the review plan intervention, and that it recognises this defect has occurred at this location in the past. It's been fixed and then it's come back again. So we're starting to be able to count how many times this has reoccurred within the last 450 days. Now, if I select, I'll select this particular top left defect because it's quite an interesting one. And as I scroll down, you can see our run and run view here. So what this is showing is over a series of runs, how that defect has evolved over time. So we can switch on and off the traces. So you can see it's progressing and it's getting worse over time. Now that is that concept that we then use to raise this as a defect that hasn't exceeded the AL level, so it's not a reportable defect. But we can see now through if I move down to the rate of degradation chart, how that's been degrading over time, and we can use that as a prediction to say we expect it to exceed the IL threshold at some point in July. So, and it's that information and it's that logic that populates our prediction dates within the table up here. Now, what you can also see on this degradation chart is work orders. So we can see here that actually we did a TAMP at some point in October, which seemed to have had an improvement in condition, but then the condition seems to have gone off quite quickly again afterwards. We also have some more interventions that were carried out, which appears to not have had much of an impact on condition. And then what's quite interesting with this one is that we actually got a work order for a ESR, TSR equipment. And I did do some investigation on this one, and it would appear that it was as a result of a rough ride report. So we can see here that actually like a pre-alert top fault and a sort of AL top fault in close proximity has resulted in that rough ride report, and ultimately a speed restriction. What we've also done, because with Insight we've now brought the PLPR information in, you can see that there's a potential voiding or top fault at that location, and we can pull back the information so we can see the images, and we can start to see that perhaps there's some signs of voiding or even potentially a wet bed at that location through that. So that's kind of giving us some insight as to what might be the cause of that particular rough ride report and might be causing those predicted top faults. The other thing that if I now zoom out a little further on here is I can actually see further down the track is I've got some cyclic top faults. And if I select that cyclic top fault, we can actually see here that we've got a pre-alert cyclic fault. So it hasn't yet got to a category D, but we can actually see from this peak amplitude chart that we've got two peaks formed there, and another one that's coming up. So once that one has degraded to the point where it's exceeded the 5 mil threshold, we might be in a situation where we have a cyclic top event there. And it's that logic that's then plotted in our rate of degradation chart. So we can see here that the left rail and the right rail, we're predicting that peak is going to exceed the 5 mil threshold around March time, and then that was degrading to the point where it's going to start to get to, I think this is a Cat C there. But what's probably more pertinent is the both rail. It's cyclic top is degraded, so we've got 2 steps there from the left rail and the right rail, and that's going off a little faster. And actually, that's looking like it's going to become a Cat A at some point in June. So this is where we're starting to be able to predict when we might get cyclic top faults. So and I think that's pretty much what I wanted to show with regards to the tool. Is there any questions on what we've shown here? Brian, were you? Sorry, I've gone.
Oh, I may not have been first, so apologies there, Rob.
That looks like you are. Yeah, you're the only one.
Okay.
Yep.
It was a quick question. You put you linked to the PLPR imagery. Is there an opportunity to link to sort of forward-facing video or the AVA type data as well, particularly around geometry, where a longer view might be a more useful thing to understand the fault than just a short section of PLPR?
Yeah, absolutely. So the bit that Martin was showing earlier with the vision for the tool and the next steps, which would be around identifying what might be the root causes of defects. So we call that intervention decision support. We want to bring in lots of different bits of information. So the forward-facing video would be a good candidate, and the AI VR solution would be a good interface into it. The other part, the other thing we're looking at is pulling the PLPR imagery, but a wider set, so potentially 22, 44 yards worth of PLPR imagery for a specific location. So you could say, I've got a defect, show me all of the imagery at that location, which would help, I think, in understanding some of the context.
Yeah, excellent. No, thanks for that, Rob.
Tim, you've got your hand up.
Hi, Rob. Yeah, I've been asking in the chat really. So, how good is the prediction at managing when work's being done? Because obviously, I think we all know that work isn't always successful. So, does it manage that successfully? If that makes sense.
Yeah. So there are some challenges with the work order data. The first one is it's entirely dependent on the ellipse data. So, if you, for example, added the work order against the whole track ID, which does happen, then it's going to assume that work's been carried out at all the locations on that track ID. So you're going to, I mean, realistically, you're going to have to look at the work bank here, the detail of that, to ascertain whether it's against the whole track ID. So here we go. We've got one there at nearly 100 miles long, or 75 miles long. So that would give you some indication that's probably not one you'd want to rely on. The other thing is that you're going to have is pulling the finish date through. So that will say whether it's been carried out or not from the ellipse work, and then you can see whether it's had an effect. So this one here that we showed where it didn't have an effect, that might be because the work wasn't carried out. It might be because it wasn't carried out at that location.
I think once we get it's worth mentioning as well, once we get to our intervention decision support release, we'll be obviously tracking the work linked to the defects in Tiger and Ellipse. And then it becomes a lot easier, obviously, because we've already worked out how you tie the peak amplitude in Ellipse back to our traces, Tim. And then obviously you've got the work linked to the defects, linked to the location correctly through the tool. There's obviously discussion how we want to then work with pre-alert work. So, we would probably manage it in Insight rather than Ellipse, but the same concept applies. You need to be able to have confidence that you're hanging the work off the pre-alert defect and not, an 89-mile track ID.
Yeah, I guess if you look at the fourth point along, there's some work's clearly been done, hasn't it? Because the track's recovered back to zero.
Yeah, correct.
And then it's degrading. So does the algorithm work off the impact of the work, or does it work off an average? Has it taken into account that sort of improvement and then obviously degradation again?
Yeah, the algorithm uses 6 and 12 measure points back. It doesn't differentiate. So here it wouldn't recognize that there's been improvement, and you can kind of see that within the chart itself. We found that it doesn't accommodate that. But what it does is it takes the worst out of the 6 and 12 run predictions.
Thank you.
Okay. Andrew, I think you've got your hand up as well.
Yeah, you mentioned earlier that you could synchronize the data with a resolution of about 200 millimeters, and a lot of the services are using GPS as the main location. That's only good for 8 meters. So yeah. How do you get the resolution to be better? Okay, so there's a couple of things we do. First of all, we run an alignment algorithm. It's cross correlation to line. It takes a signal, actually takes a signal from the top right trace, and it will match it based on that signal. So it shifts the measured location left and right slightly, squishes and squeezes it to get the traces to line up. So that's the first thing it does. It doesn't always get a perfect result from that. The second thing we do is we aggregate it. So we get the measure points every 200 millimeters, but then we take an aggregate over a yard. So we take the worst point over a yard, and we'll compare that run on run. That's what we use to give you your degradation at a yard level. Then using the persistence, a hysteresis rule for the geometry, you get a start and end location for the defect based on the yard degradations. And finally, we
aggregate that up again to the whole defect. So what that means is that we compare the peak point from each run within that defect run and run, so that you could, for example, you compare that point with this point with that point, rather than comparing, say, that point with that point for the same location. So sorry, there was quite a bit in that. I don't know if that made sense.
That's a very good answer, and and it also says it's a relative calculated resolution rather than an absolute, so that getting down below GPS as an absolute measurement is still a priority.
Yeah. I mean, the theory with taking the relative measure is that over a series of runs, so maybe 12 runs, there should be a normal distribution about its actual location. So as well as comparing run and run, it should give us theoretically should give us a more accurate real life location.
Thank you.
Kevin?
I'm not sure whether I saw it or not, but are you looking after level ones?
Yes. So we do have level ones in here.
Because if we look at somewhere like the West Coast Main Line, touching head, the number of level 2 faults that we have on the West Coast Main Line is quite insignificant in relation to other routes, etc., because of what's happened in the past. And we would probably say that we would want to manage the level 1s to make sure that we weren't getting level 2s.
Mm-hmm.
So we were being proactive as opposed to reactive. So we would be removing high level level 1 faults, as it were.
Yeah.
And then also having some form of prediction on the level 1s to when they were actually going to cross the threshold and become a level 2.
Yeah, absolutely. So the main, the target for us is to move to the point where we are managing things at level 1. And there's a couple of things that help with that. So one is obviously we do the predictions, and we can say so that even if you've got an AL exceedance there, it will give you the prediction to the next threshold. So IL within a certain time scale. So we can say, well, this is an AL, but it's flatlining, so it's not going off to IL, or this is an AL and it's going off really fast, and maybe it's going to IL obviously not on top. But so that helps. The other thing is that this persistence rules. So the fact that it will report the defect, then you might plan to work against it. And then let's say you've got I don't know, 6 months based on the prediction dates till it's going to get to the point where you've got to action it. You can keep that work in there, and it will recognize next time it's recorded. So it might get recorded 6 times in that 6 months. It keeps that defect, keeps that work information against it, so that you don't have to keep reconciling it to the work you've already planned. And that's something that we're calling persistence. And that should make the whole process a lot easier to manage with your lower level faults, with your L1 faults.
Yeah. Okay. Thank you.
And the reason why on that, Kevin, we wanted to do the RBM stuff especially was obviously we had to build a tool to start with that covered the whole country. And then we know different people are in different places in regards to how they're managing defects. And a conversation I had with Johan Strydom quite early in the whole process, and that's why we fed this back and we're trying to get this RBM bits in place, is because he's talking about measuring things 2 millimeters lower than what the AL threshold is.
Yeah.
Depending where we are. So that's why we're trying to get that in as quick as we can, so that it does make this tool usable across the whole country.
Yeah, well, of course, we can then use that to support things like sprinter tamping to remove the level 1s before they become level 2s.
Yeah.
And then do a lot of them within a possession if they all come together. You mentioned about just one more thing from me. You talked about the RBM, and one of the questions I raised earlier was for the yearly review of the RBM regime, where we need to carry out a reassessment of what's being found in the year, and whether the the current RBM baselining is still correct for the next year.
Absolutely, yeah. I was about to respond to that, and then Paul called my name, so I dropped that one. But yes, absolutely. So the idea
Any
is
tools or support that the application could give on that.
Yeah, so that's certainly the intention. So the first bit is we're building in the RBM rules within Insight, so you can configure it in the back end. It will apply the revised thresholds, and therefore you don't have to just do it at AL. You can set it to whatever threshold you like.
Yep.
And then it applies you can set your failure modes and against the defect, and the remedial actions, all the stuff you would expect, I guess. But because we've got all that information within there, it absolutely makes it very useful for doing those reviews and improving the RBM rules in your regimes, because we'll have the failure modes against the defects, we'll have the predictions, we'll have the degradation charts, all of that kind of stuff. So we're working with Fraser Todd on regularly on a day-to-day basis on this functionality. So
yeah. I take it then you'll probably also be looking to support with the number of 3064 TEF failures that you've had within the regime area as well, because wrong side failures track is also another one of the parameters within the RBM regime.
Yeah, so I mean, this initially it won't have that information.
Oh yeah,
in,
you're walking rather than running. Therefore,
yeah, absolutely, yeah.
Okay, thank you.
Okay, I think Tim, you got another question?
Yeah. Oh, he's forgot to put his hand down.
Sorry, no, I haven't. Yeah, just couldn't get off mute then. Regarding the positional system, have you done any analysis with the recordings they're using, the 153s are doing with machines with vision against what the conventional measurement trains find? Because obviously that's meant to be down to the sort of 10mm level, isn't it, for absolute accuracy?
So we haven't done that yet, Tim. We had a meeting with the IM team yesterday about these sort of things going forwards and how we're going to work together to do this. So the only other measurement systems we've looked at so far are from the Hitachi units on taking their data. And so yeah, so there is part of the ongoing work with the IM team.
Cool, thank you.
Okay, I'm going to take back over. We've got a little video to show you, and then if there's any final questions, please just shout up. Because what I don't want to do is you just take our word for how good we think Insight is, and we do think it is a very, very good tool. What I want to do is quickly show you a video that was made with colleagues out in the Anglia route of what they thought of the tool. Perils of doing this. So as you can see from that, it's not just us that think the tool's good. The tool has been out in pilot in a number of areas across the country. So Kevin, in your patch, it was Manchester South. We got some really good feedback from people like Wayne Lennon, who's been fantastic at feeding stuff back to us. Stu Gordon, Stu Orange, those sort of people been really helpful in giving us the feedback on the tool that we need.
Yeah. There's some comments that have now come through, which you might like to, or questions which you might like to answer. From Peter Cowans. Are you sharing lessons with TfL, who have been using data map for some time, brackets for some stuff, and RFL, who are maturing through the use of TrackNet with all discipline related asset monitoring? Also linking it into RV/VR/digital twin type tools, which can be used for simulation of prevention and planning, etc.
So I can answer the first bit on regarding with TfL and RFL. So we have had some discussions, and I was asked the other week to look at how much of our tool, for example, covers Crossrail, to try and work together with those. So we are looking at doing that. Martin, do you want to pick up on the second part?
It's an IM initiative at the moment, so we would look to feed off anything that they do in that space of digital twin. That's infrastructure monitoring program.
Yeah,
for those who don't know the acronym.
There was a couple of sort of little bits and pieces that I'd asked in passing. One you've already answered in the sense with AVIR to Brian, and the other one was you talked in terms of lost recording runs, etc. I take it you are plugging into the new P&C tool, which is under development at the moment.
I think we talked about that today. So is that the one that manages the timetable and then the misruns and everything else, Kevin? The new?
Yes, it is.
Yeah, so we want to utilise that going forward to make sure we get those misruns identified, but it helps us then filter through all the locations where we get like 6 runs go over it in a day and pick the right run.
Yep.
So that's what we would be using that for.
Now, at the moment, it's in UAT testing.
Yep.
Or it's about to be into UAT testing.
So we had the instruction to align on that this week, and we've created what we call user stories in our backlog to help us then utilise that for compliance, etc. So we're definitely going to use it.
Cheers.
Great. We got a hand up from Andrew as well. We've got Andrew's got a hand up.
Yeah. So my question is, relating to some of the fantastic developments you've done there, what remains a really important challenge for the future research and development of this program? So we're based in a university. We've worked on this kind of problem, and it's really important to get some feedback from the users to say, yeah, this bit's working really well. Synchronization you described, for example, but no doubt there are some areas that still need a bit of focus or pose challenges for the future.
100%, Andrew. So what we do is we don't do a release until we meet the initial success criteria that the customer sets. So in this example, we did backcasting, what we call backcasting against our algorithms, to give a percentage of, if you'd had this 2 years ago, how many of these volumes of faults that came on would have got a prediction, and they're giving you enough time to plan to mitigate it out. I think the initial, and Paul correct me because he did this bit of work, but I think the initial customer success criteria was 70% of historic faults would have been predicted. I think we got higher on cyclic top, Paul. Was it 98%?
We got higher than 90%, yeah, and then we got around 72% on track geometry faults.
So obviously we can release the product based on that success criteria. As we go forward in my team, we're always trying to refine it further. So obviously we've met the initial criteria of 70, and then as a program you would say, well, if we could get it to 80, what do our percentages do? Our numbers, yeah. is there an appetite to do it? And then internally we look at it. And now obviously there's a bit to be said with universities that if we can't do this internally, then we look to go out to the supply chain. I think we're working with Southampton University at the moment, Paul, around S&C, our point operating equipment prediction model versus changes in geometry and weather. So we're always looking to expand our knowledge base, but it is driven all by customers to say, like you identified, is it good enough? Yes, no, what? And then obviously continuous improvements, the buzzword, right? So, you know, it's all very well creating a product, but we can't just leave it out there now. It's got to continuously evolve as the data and the intelligence and the business strategy evolves.
Brilliant, thank you. I think we might be in touch for a chat later. Cheers.
Thank you, Andrew. I shall look forward to it.
Perfect. We've got a question from Graham now. Go ahead, Graham.
Yeah, hi, afternoon. Great presentation. Just a quick one. If you're external to Network Rail and you're a track designer, for example, and you haven't got access to NR tools, will that be rolled out at all to use? Because it would be useful in terms of trying to identify track geometry.
Very good question. So
identification.
Overall, sorry, Andrew.
That's all right. No, that's it. I've already finished. So, yeah.
Sorry, so the product itself is available to external users. So because it's cross-discipline for structures and for various SMTH scripts and signaling, it is available to external users. I guess it's just a case of going, we would approach you to say, what's your business case around it? And then if it stacks up, there's no reason external users can't get access. You just wouldn't be able to action any of the defects in the tool. But we have the concept of grazing. So users that will use the tool to graze, they might look at defects, they might look at the, you know, the track quality, they might look at a trace review, which is fine as long as they can't take any actions. So, you know, if there's a business case to say us having access to this means we can offer you a better service, then yeah, we're all for it.
Brilliant. Andy's got a hand up. Andy, go ahead, Andy.
Cheers, Ian. Thank you. Yeah, great presentation, guys. It's really interesting to see some data being pointed in the right direction to allow people to make real-time engineering decisions. Just my question: is there any way of us being able to somehow extrapolate the data and then feed it into a maintenance design tool, so that when the techs are sort of working to build designs for tampers to implement, we can use the data that's taken from this tool to help build that design to save our guys putting unnecessary boots on ballast?
Yeah, so there's two bits to your question. First is, yes, everything in the tool is exportable in CSV, so you can export the defects. But obviously that in itself is a use case that we'd want to explore, that says, you know, one of our releases is around tamper effectiveness and how far you are down your sawtooth in terms of tamping, stone blowing, and then renewal. So if you have a user journey or a use case that says, for the decision I want to make, this is my journey through the product, we would look to implement that within it. But otherwise, all the data sets that will find their way in or are in there today are exportable into CSV. But I'd like to maybe get together, Andrew, and talk that use case through. When I say I mean Rob. But yeah, that would be really good.
Yeah, no, just because shout whenever. I think for me personally, it'd be good to see if we could extrapolate that data and overlay it onto a design route survey, and then understand how that plays out, and then so you can kind of use it then as a maybe a design. I don't know. It's just
yeah, no, sure, I get it. Yeah, more than happy to have a conversation about it.
All right, cheers, Mike. Thank you. Thanks, guys.
No problem.
Brilliant. So I think that brings us to close, and just for me to say, you know, amazing, thank you, and presentation, the way it went through. Every time you thought of something new, you went to a new screenshot which answered it for us, and then some of the questions that came up were pretty hard questions, and you just sailed through them and give answers that I struggle to follow sometimes. So
we really gave answers, Ian. I'm not going to say that they're right. You know, we know what we're talking about or anything.
You fooled us anyway. You fooled us. It was
just to say that Alex Schock and I will be at the PWI conference next Thursday in Birmingham. So if anybody wants to come and grab and ask more questions, I'll bring my laptop with you and with me, and we can soon do some runs through and have a look if anybody wants to meet in person and ask us any questions there as well.
Fantastic, and I think you guys brought it to a new level with the questions in the chat as well. Answer them as you go in. So you know, really good. This is showing how good a online meeting can be. So, could everybody join me in thanking the presenters in the usual manner? Thank you.
And thanks for hosting us, guys.
Yeah, thanks
I've
very
got
much for having us.
Yeah, I was just going to hand over to you. Go on,
yeah,
Kevin.